Alright, I want to show you guys an example of why topology can be really important. Alright, so I'm going to show you a situation in which having bad topology is going to cause you a real problem. Now, topology is something that everybody knows you should be doing right. Everybody knows you need to have good topology, only quads and triangles and all that stuff, no n-gons. But I'm going to show you an example, a practical example of why exactly this can be a huge problem, right? And then maybe we can look at some more examples in another video, but I'll show you over here with this cube right here, okay? And the example that I want to show you is if we take this cube right here and we cut a hole into it with a Boolean modifier, okay? We're going to add a cylinder and then we're going to use our Boolean modifier to cut a hole in that cube using that cylinder, okay? We're going to go to set it to our difference, and once we delete the cylinder, we have this hole, okay? Now this hole has a whole bunch of n-gons over here. We have polygons here which have like 30 different vertices on them, or 20 different vertices on them, which is the definition of really bad topology, right? This is a really classic example of bad topology. You don't want to have n-gons, you want everything to be triangles or quads, ideally quads, all right? So this here, even though right now on the surface it looks like it's pretty good, and maybe sometimes you can get away with it, but I'll show you an example of when this can be a problem, okay? I'll make another example over here of another cube to demonstrate to you what would be the right way to do it. So then we're going to simulate that situation which would cause the problem, and you're going to see why we need to have this second example, why it's better with better topology, right? So in this case, I'm going to delete my cube and I'm going to create a hole. I'm not going to delete the cube, I'm going to delete the face on top, but I'm going to cut a hole in this cube using good topology. Okay, so I'm going to do the same thing we have over here, but we're going to have good topology on this second cube, all right? So we're going to take this cube and we're going to add a couple of loop cuts around the side. We're going to extrude those inwards and turn them into a circle, all right, like this. And we can fill it in and extrude it inwards, and then once again we can extrude it down like this, so we have triangles, or maybe we can turn those into quads, so we can just remove some of the edges here in the middle, and now we have only quads on this model, right? So it's basically the same thing, except this one has good topology and this one has really bad topology, okay? But it looks pretty much the same from over here, right? So I'll show you an example of when this can be really bad, right? And the best way to look at that is if we add a subdivision surface modifier, all right? So look at what happens. If we add a subdivision surface modifier to the first object with good topology, it looks pretty much like you would want it to look with a subdivision surface modifier, right? It gets pretty smooth and round, and it's almost like it's kind of melted. It turns into like a clay object. But if we add a subdivision surface modifier to the second object, look at what happens, all right? This looks completely atrocious. This is definitely not the result that we want if we add a subdivision surface modifier to this object. Now, on top of that, the other problem is that we can't really... Well, when we have a subdivision surface modifier on an object, you can add a bunch of loop cuts to kind of tighten the edges, to control the edges, to make them flow a little bit better, you know, to make the object look a little bit more, you can have a lot of control over the shape, because by adding loop cuts and changing the topology and stuff like that, right? So we can make it a little bit tighter on the corners and all that stuff. But over here, if we want to do that, okay, we can add some loop cuts over here. We might even be able to add a loop cut down here, but it doesn't go all the way around, and we definitely can't add a loop cut anywhere on top, right? So if we add loop cuts over here, we're definitely gonna have a big problem. See, over here we could easily add a loop cut to the top around this hole, but over here we cannot do that, right? Over here it doesn't let us do that because of the bad topology. Blender does not know that when we want a loop cut, we want it to go all the way around this hole. That's because of the bad topology, right? So that's an example of why you really want to have good topology when you're creating something in Blender. Now, if you're making an object when you're not going to use a subdivision surface modifier, maybe you can get away with your really bad topology. But there are other examples of when you can have problems because of bad topology. So here's another little simple example of why bad topology can be a problem, right? So here, another situation is if we add smooth shading to this object, all right? We select our cube, we go to object menu, and we add smooth shading, right? It's going to start shading the edges a little bit smooth, but the edges are pretty sharp, so it's not going to work very well. But if we kind of round the edges, it's going to look alright. Anyway, the point is that the smooth shading works kind of like it should on this object, right? There are no major problems. We just need to adjust the object a little bit, right? We can do that by just moving some of the edges around, making them round and all that. And then the object is going to start looking a lot nicer, right? The smooth shading starts looking a little bit more realistic. But over here, if we add smooth shading to the object, which has terrible topology and all these different n-gons and stuff, we are going to have problems. We're going to have some visible artifacts on the surface of this object. Like you can see these lines over here. They shouldn't be here, right? We don't have those lines on this object. So bad topology, and especially n-gons and even long triangles, they can cause these kind of problems as well. So this is going to be another thing that's going to give you problems. Now I'm pretty sure you would also get a bunch of problems because of this topology if you were to use some other modifiers, especially the deform modifiers, right? Because this surface, it's almost organic, right? So this surface can kind of bend without causing too many problems. You can just kind of bend the individual faces and have like a bent surface. For example, if you were to use a shrink wrap modifier on a surface like this with good topology, it would nicely wrap around a surface. But if you use it on a surface like this, Blender cannot bend this surface correctly, right? It will be a complete mess. So you can imagine that modifiers become a lot harder to use, shading becomes a lot harder. So there are already two major problems that are caused by bad topology. And I'll show you another little tip of why using good topology can actually be very beneficial, especially if we're doing something like cutting holes. But when we're modeling something, using good topology makes it a little bit less destructive, all right? So we can have a little bit more control over the modeling if we use non-destructive, good topology kind of modeling, right? So for example, let's say I want to make another hole in this object over here, right? I can just take a couple of these faces, I can inset them, and I can just extrude them down, and that's easy. Or maybe I want to make another little circular hole, so I can do the same thing over here, scale that down a little bit, and use some loop tools to turn it into a circle, right? And then I can just extrude that inwards as another cylinder. That's very easy. But over here, we can't really do that, because if we inset this face, we have this big mess. We can't really add any loop cuts. We can't really turn this into a circle. It's going to become a complete mess, right? It's really a lot more clunky to model. It's really a lot harder to work with, right? Now, we could go ahead and manually join some vertices like this and just add a loop cut over here and, you know, do stuff like this. But this is it's a lot harder to do this. It's a lot more problematic. We still have a bunch of n-gons and other problems, you know. We could also go ahead and use another Boolean modifier, but then that would just look like another circle over here, right? Another circle which is connected with terrible topology, and it will be a really big mess if we use another Boolean modifier over here to make a hole, right? So modeling just generally stays a lot easier if we have good topology. It's a lot cleaner. We can once again just subdivide this a lot better and just add loop cuts and have more control over how we create this model. So that's a very good example of why topology is really important and why it's really helpful. So if you're not going to use any subdivision surface, if you don't care about whether it's destructive or not, if you don't care about shading, if you don't care about UV unwrapping, if you don't care about your modeling process later on, you don't have to use good topology. You can just use n-gons and booleans. It's not a problem. You can get away with it in some situations. It's really not a problem necessarily by its nature, right? But it causes some things to the model which may give you trouble down the line if you want to do something else with the model. If all you want to have is a cube with a circular hole in it, go ahead, knock yourself out, use a Boolean modifier. But if you want to do something else with it, chances are you're going to run into some problems. So it's really important to use good topology. If you guys want to have more lessons like this about topology, you want to learn more about how to create good topology and how to structure models with better topology arrangement and stuff like that, let me know in the comments. We can make another video on that. But I'll see you guys in the next one.